intervals of increase and decrease, which we will talk about in just a minute. Now, domain and range should not be new to you. You saw it back in Math 1. Intervals of increase and decrease, still not new to you because you saw it in Math 1 as well. But you're used to intervals of increase and decrease being just in one direction. So just an interval of increase or just an interval of decrease. Whereas with quadratics, you have both. So you have an interval of increase and an interval of decrease. But we'll cross that bridge when we get there. All right. So with page 9, we're actually just going to be introducing what a quadratic function is, which you did see a little bit of back in Math 1. All right. There was at least one unit in there. Very brief, though. But we're actually going to be going in depth with the quadratic function. So everything that it's used for, the key features with it, and then later how to solve them. So the solving is not going to be in this unit, but it is its own unit for a reason. All right. So you guys should already know what linear and exponential functions are, because again, Math 1. And they're always either increasing or decreasing. There's no in between. But quadratic functions, which is a type of a polynomial function, so that's why we reviewed polynomials yesterday. So a lot of those features of polynomials applies to a quadratic. And what it is that it's a function that both increases and decreases. All right. Now, typically the standard form of a quadratic function is this right here. So get very familiar with that. You will be using it a lot. So this is the standard form of a quadratic function. Now, why am I calling it the standard form? Because later on this unit we'll be learning 2 other forms. But just know that this is the standard form. It's in order from the highest degree to the lowest degree. Now, something important to note is that your a value, so the coefficient, cannot be 0. So the leading coefficient cannot be 0, but b and c can. It doesn't matter if b and c are 0. The a value is the only thing that just can't be 0. All right. Now, let's look at exercise 1, talk about this. So the question is, why is it important that the leading coefficient is not 0? So in other words, why can we not have y equals 0 x squared plus b the x plus c? All right, any thoughts on why that would not work in terms of a quadratic function? Say it again? Wouldn't necessarily equal 1, but you're on the right track with that. So something with 0, what happens with 0? What equals 0? Whatever you multiply by. So what happens to the x squared? It's gone. So if the x squared is gone, that means we'd be left with the bx plus c. Well, is that a quadratic function? No. So what Sun said about being equal to 1, the degree would then be equal to 1, not 2. Remember, a quadratic function has to be equal to 2. The degree has to be equal to 2. The highest exponent has to be a 2. If it's a 1, it's a what type of function? Linear. So basically, to sum it up, the x squared would cancel, and we would no longer have a quadratic function. So as long as there's an x squared somewhere in the function, it could just be y equals x squared, nothing else after it. It's a quadratic function, all right? But as soon as you take away that x squared, it's not a quadratic. All right, so let's look at letter B. All right. And we're going to determine Which of these is or is not a quadratic function? All right. So not only does it need to contain an x squared, the x squared has to be the highest exponent, and all the rules of what makes a polynomial that we discussed yesterday still apply. All right. Hint, hint, wink, wink. So x squared minus 3. Thumbs up if you think it's a quadratic. Thumbs down if you don't. 1, 2, 3, go. So x squared minus 3, is that a quadratic function? Yes or no? Yeah, it is. It has that x squared, even though it doesn't have an x value, since it has the x squared, it's considered quadratic. What about the one to the right of that one? So the top right. Yes or no? Thumbs up, thumbs down. Definitely not. Why? Right, because the highest is not 2, it's 3. Okay. What about the bottom left one? So y equals x squared plus the square root of x plus 7. Yes or no? What do you think? Thumbs up, thumbs down. I see some thumbs down. I see some thumbs up. The correct answer is no. Why though? Because it has that x squared. Right. So since a quadratic is a polynomial, all the rules of what makes a polynomial still apply. And one of the rules that says that it cannot be a polynomial is when x is underneath the radical. All right. So because x is underneath that radical, it's not even a polynomial function, let alone quadratic. What about the last one? Yes or no? Yes. So these two are my only quadratic functions there. All right. Now, letter C, we're going to put this quadratic function in standard form, and then we're going to state the value of the leading coefficient. So let's go with William. What would be my first term? Right. Y equals negative 3x squared. What's my next term? Caitlin. Good. And so that means we end with the plus 10. Now, why is that considered its standard form, Amelia? Right, because the exponents are in descending order. All right. So, that being said, what is my leading coefficient? Sutton. Negative 3. So remember, it's the coefficient connected to the variable with the highest exponent. So in this case, the x squared. Now, let's do some calculations here. So we're given this quadratic function. They want us to find the value of f of negative 2. All right. So first, if we're finding f of negative 2, all right, what does that mean we have to do? Plug it in for the x's and then evaluate it. Good. So this would be 2 times negative 2 squared minus 3 times negative 2 plus 1. All right, so take a minute. Without a calculator, evaluate that. All right, remember, PEMDAS applies. All right, if you need to confer with your group to check your answer, you can. All right, thumbs up if you're ready. One more minute. All right. One person raise their hand. Tell me what you got. Eli. All right. Did anyone get anything different? All right. Anyone else get anything different? All right. So the correct answer is 15. So make sure that you only square the -2. So that'll give you 4. Remember, it's positive. -2 times 4, which is 8. -3 times -2 is 6. 8 plus 6 is 14, plus 1 is 15. Now, that's our output. So if I were to write this as a point, what would the point be? So would 15 be my x or y value here? It's your y, it's your output. What do you think the x value would be? -2. So this would be the point on the quadratic graph. All right. Now, quadratics have very similar ways to other functions. The inputs go in, the outputs come out, of course. But they behave differently from linear and exponential. All right. The biggest difference is with linear and exponential, your y value is never repeated. With quadratic functions, your y values or outputs do repeat. All right, because it's a symmetrical function. Meaning if you cut it in half, fold it over each other, it's symmetrical. All right. So we're going to fill in this table for f of x equals x squared. So in other words, we're just going to take every one of these x values and square it. All right. So let's just go through this together. What would -3 squared be? 9. -2 squared? 4. -1 squared? 1. 0 squared? 0. 1 squared? 1. 2 squared? 4. 3 squared? 9. All right. Take a minute and graph those points on the graph. All right, so remember, a quadratic has a U-type shape, so your graph should be a little bit curved. Do not draw them as straight lines. That's a completely different type of function. All right, so it should look like a U, not a B. A B is an absolute value function. All right, so then it asks, what's the range of my function? So just to review, range is what values? Y values. So you're looking at the up, down. So what would my lowest Y value be? 0. And we're going to write this in interval notation. So what's the highest Y value? Infinity. It goes on forever. Now, we know infinity has a parenthesis. But what do you think 0 will have? The bracket? Yeah. Why would it be a bracket and not parentheses? It's included. So, since it's an actual defined value when x is 0, all right, or y0 is actually a defined value because it's even in our table, all right, that's why we use a bracket. So, another way you can figure out bracket versus parentheses. Bracket means defined, it equals that number. Parenthesis means undefined, or it gets really, really, really close to that number, like infinitesimally close, but it never actually hits it. All right. So I tell my kids, you guys know that meme where it's like Lilo and Stitch, and Lilo's like doing this to Stitch, and he's like, "You're touching me, you're touching me." I'm not touching you. That's how I think about it. All right. All right. So this is where I want you guys to use some Desmos. So go on to Desmos, the graphing calculator. So here, to make it easy for you guys, I can just do this. All right, so what I'm about to do, it'll make Desmos automatically open for you. And this is the testing version of it. So Desmos should automatically open up for you. It's the testing version. So how this works is, when it opens for you, what you need to do is make sure you hit, as soon as it loads, choose assessment, scroll down till you see North Carolina, click it, make sure graphing calculator is highlighted, and then hit start practice. All right, this is the exact calculator that you'll see on your Math 3 EOC. It's the one you saw on your Math 1 EOC. The one with the green bar is actually the outdated version. So what I want you guys to do is, for this function right here, I want you to take a minute and I want you to do letter A and B. So you need to generate a table in Desmos, use that to graph it, and then state the range. All right, does everyone remember how to generate a table for a function in Desmos? Or do I need to go over that? Okay, so I'll show you how to generate the table. So everyone look up here. So I'm going to type in the function. So it's y is equal to x squared. What is it, minus 2x? 2x, and then plus what? Minus 8. So what I'm going to do is I'm going to hit the gear key on the top right of my little input area. Do you see this little table icon? Click it. There's a nice table for you guys. Great thing about Desmos tables is that if you need more points, you can input any x value you want. It'll automatically generate the y value. So if I put in 3, there's my next point. All right. So generate that table, copy it down, graph it, and then find the range. So I'll give you guys about 3-4 minutes to do it. So I'll give you to 8:40. So you need at least 5 points. So whatever that table is originally, that's what you need to copy down. So you just need to do A and B. Don't worry about C. We're going to talk about it. One more minute. All right. So check your work. So I just copied the table straight from Desmos. I graphed it. And then for the range, you should have gotten -9 to infinity. So -9 is your lowest y value. It has a bracket. And then it goes on forever upward. Any questions on those two? All right. Now, intervals of increase and decrease. All right. This is where part C comes into play. So it asks us to find the domain interval where the function is increasing. Now, domain means what? X values. So intervals of increase and decrease are always going to be X values. All right. So here's a trick. Even if you're not looking at a hand-drawn graph, if you're looking at Desmos and, the X's and Y thing confuses you, like especially when you're doing domain and range, because I know it can get confusing because there's so many different numbers. But if that confuses you guys, here's a little trick. You hit the wrench key. You can actually turn off axes. So I can turn off the y-axis. It's not there anymore. So all I see is the x-axis. All right. And it helps because when I'm doing interval notation, I only want x values. So I don't even want to look at the y-axis. And then if you want to turn it back on, all you got to do is just make sure it's checked again. And now it's back. All right. So that's just a little Desmos trick, especially if, domain and range sometimes confuses you. That's okay. Because that's something that confuses a lot of people. All right. So this is how we do intervals of increase and decrease. With the quadratic function, it has both an interval of increase and an interval of decrease. All right. The way you figure it out is what I do is that I start from the leftmost part of the graph. So right here. And I just travel my pencil along it and ask myself, what am I doing? So if I'm doing this, what do you guys think this is? A decrease or an increase? Decrease. So this is an interval of decrease. Now I stopped right here at the vertex. All right. This is the vertex is also known as its turning point. And it's known as a turning point because as soon as we hit the vertex, it changes direction. So now, once I pick up at the vertex, what am I doing? Increasing. Ugh, I didn't do that. So this is an interval of increase. So for letter C, it's asking us what's the domain interval that's increasing. So we're looking at the red part that we just highlighted. So that's what you do. You always go from left to right because it's x's only. So you start with the leftmost point, run your pencil along the graph, ask yourself, am I going down or up? Hit the turning point, go in the opposite direction. All right, does that make sense? All right, so now let's write a interval to describe this. So we're looking at increasing, we're looking at x values only. So at what x value does my interval of increase, or the red, start? -1. Nope, not -9. It's +1. So remember, x values only. So that's why if you were looking at Desmos, that's why I said, turn off the y-axis so that the other numbers don't throw you. Right here's the turning point. It's right at 1. All right. So we start at 1. Now Now let me ask you this. Do you think I'm going to use a bracket or a parenthesis here? So I'm hearing mixed answers. Let me ask you this. Is the turning point increasing or decreasing? It's neither. So it's the gray area, it's neither. So can we say that 1, so where it's like neither increasing or decreasing, can we say that 1 is an exact spot or exact x value where we're increasing? No. Because it's kind of the gray area. It starts increasing at x values infinitesimally close to 1, but it's not going to be defined there. All right? So, parentheses. Essentially, guys, intervals of increase and decrease, you always use parentheses. All right, that's where I'm getting at. Now, where does the increase interval stop? What x value? Infinity. It goes on forever. And that would be our interval of increase. Now, interval of decrease, just flip it. It'd be negative infinity to 1. All right, that's the great thing about quadratics. Once you get one of them, flip it, you got the other. All right. All right. So letter D, what is the coordinate of the parabola's turning point? So remember, we call the graph of a quadratic a parabola. And remember, the turning point, I already said it. It's the vertex. So it's the max or min point. In this case, it's the minimum point. So what's the point for the vertex? It's at 1, what? -9. Now, axis of symmetry. Does anyone remember what an axis of symmetry is? The line that what? So it's a line that cuts the graph in half, right? Right. So it's symmetrical. So where do you think I'm going to draw the axis of symmetry? What point do you think I'm going to draw it through? The vertex. Good. So if we draw the axis of symmetry, it's going to cut right through the vertex. Now, Audrey, why did you say x equals 1 as the axis of symmetry? It's on the x, but also it's a what? It's a vertical line. So when we write an axis of symmetry, we always have to write in terms of x equals whatever the x value of the vertex is. So x equals 1, that's our axis of symmetry. And the reason we do that is because this is a line, all right? So if this was on your test and I asked you to state where the axis of symmetry is, if you just say 1 and not x equals, it's wrong, all right? Because it needs to be an equation of a line. Now, what about the x-intercepts? What do you think? So where are my 2 x-intercepts on this graph? -2 and where? 4. So you can also look at your Desmos version because you may not have graphed it. But I did. So at -2 and at +4 are my x-intercepts. So this will be at the point -2, 0, and guys, we love the technical difficulties, don't we? All right, so it's at -2, 0 and 4, 0. Now, x-intercepts are also known as the zeros of the function. So remember, there's a bunch of different words that are synonymous to x-intercepts. It's zeros, roots, and solutions. All right, so you'll hear that interchangeably a lot. All right, and we'll come back to that in a little bit. But these will be are two coordinates. Okay. Now, you'll notice those functions zeros. Why do you think they're called the zeros? They're on y equals 0. All right. So in other words, it's where the function is equal to 0. That's what that means. It's where f of x is equal to 0. That's why it's called the zeros. Because remember, your x values are just inputs. When we're talking about function, we're talking about outputs. Now, let's look at exercise 4. So this time they gave us a table, no graph. All right. And they didn't tell us the equation that goes with it, and we don't really care, to be honest. We just know it's a quadratic and that f of x is represented by the table. All right. So if we look at the table, do you think we could figure out where the vertex is? Yes. How do you think you'll figure out where the vertex is? What numbers?
The y.
The y's. So you look at the y's. Remember, quadratic has increasing and decreasing. So if you look at the y values, looks like they're increasing. They hit a number, and then they start decreasing. So the value where they switch from increasing to decreasing, that's where your vertex is. So where do you think my vertex is at? 213. Because that's where our y values went from increasing to decreasing. So that's our vertex. Now, what would be the range of this quadratic function? And we're just basing it off the table. So what's my lowest y value? Not -1. We're going to y's. So -2. What's the highest? 4. Nope. Highest is 13. So lowest x value, not x value, lowest y value, highest y value. Now, do you think I'm going to have brackets with these or parentheses? Brackets, they're defined. And honestly, with the table, unless it's stated otherwise, you would definitely use brackets, always. This table is usually a set of defined values. All right, any questions on this? All right, so just to make sure that you guys are good with all the vocabulary with the features, okay? The next page is a nice little kind of breakdown of all the different features you have. Okay? So, first things first, we got our x-intercepts, which are right here. It's where they cross the x-axis. You have your y-intercept, where it crosses the y-axis. We have our vertex, so it's the turning point. And we have our line of symmetry, which again in this class we call it the axis of symmetry. And it is where it cuts our graph in half, so right here. Now, some other features that we need to be aware of, all right, is whether it's opening up or down, that is what we call concavity, all right? So if we're talking about direction of opening, all right, we call that concavity. It's just a fancy word that says what direction is this graph opening in? Is it opening up or is it opening down? So if it's concave up, it's opening up. Concave down, it's opening down. Now, could I just say what is the direction of opening? Yes, but if any of you are going into pre-cal or calculus later on, you know what concavity is. Then we also need to know minimum and maximum, and that relates to the concavity. So whatever the concavity is, that tells us whether we have a max or a min. So whether the vertex is the highest value or the lowest value. So if our parabola opens upward, we would have a minimum y value. So again, it opens upward if the y is the min. Or not the y, the vertex. Sorry. So the vertex is the min, it's opening upward. It opens downward, we have a maximum y value, so that means our vertex is the max. So let's kind of put it all together and identify everything in this graph. Okay. First off, what's the concavity or the direction of opening? Is it going up or down? It's opening down. So based off of that, are we going to have a max or min? Max. In other words, our vertex is the highest point. All right. Take a minute, find the axis of symmetry. And Claire, you're going to be the one answering it. So Claire, where's the axis of symmetry? Where does it look like the graph gets cut in half? So it's -2, like that's the x value. So wouldn't the axis of symmetry be that x value? Yes, good. So our axis of symmetry is right here, and it's at x equals -2. All right. So what would the vertex be, Eli? -2, 4. Good. That's the vertex. So that's a -2, 4. We already said we had a max. What is the y-intercept, and Bradley? Yeah. And what's that as a point? 0, 3. So 0, 3 is your y-intercept. Name me one x-intercept, Reynolds. So 2, 0 is one of them. What's the other one? Reagan. No, it's -6. So -6, 0. You're right the first time. Now, think about this carefully. What will my domain be, Lucas? So, what x values am I using? So, you go from lowest to high. So, what's my lowest x value? Not -5 quite yet because we have these arrows on the end. So, that means it keeps going on forever. So, what's the lowest x value? What's the highest? Right. So the domain is from -infinity to +infinity. And another way you could state that is all real numbers. So if you want to shorthand that, that's a capital R with a line through it. And that's always true for a quadratic. All right, so they give you just a normal quadratic graph. The domain is always negative infinity to positive infinity. The range is the only one that differs. That's why the past questions, they only asked us for the range because the domain was always the same. So what would my range be, Kate?
A bracket and 4, and then with a parentheses.
Say that one more time.
I did a bracket and I did 4, then a positive infinity.
Okay, so you're close, but here's my question. It's for your highest y value or your lowest? It's your highest. So what would be so if we're going to infinity, that means it's higher than 4. Right. So you just flip what you just said. So it'd be from negative infinity to 4, and then you put a bracket. So since 4 is our highest value, we've only seen it where it was our lowest. But since it's our highest, we start at negative infinity, then we hit 4. Remember, you start at the bottom and you go up. All right, any questions on any of this? All right, so your homework for tonight is page 12 and 13. All right, and then for that delta math, I will give you till tomorrow by midnight. All right.
You know those topics we have? Those are a lot of numbers, but they're done, but I just haven't been doing
Is it ones that I've like already checked?
some parts of it, not all of them. Sometimes you use some class and I just copy off that. So,
Yeah.
I can show you examples.